so far away. You live around here? We do live around here. Not too far. A couple miles?
Straight east.
It looks like they're kind of every other chair. So it looks like
it's a position of distinction. Yeah.
no.
Hello everybody, welcome in tonight. We're going to be starting in just a few minutes, but in the meantime there are resources back here, on this book table back here. If you see something you'd like, just pick it up and take it to your seating queue and then we'll check you out afterwards. On the back table, as you come in the door, those resources are free for the taking, so just pick up whatever you'd like. And our mailing list is back there if you'd like to sign up. And back here in the back, we have lots of refreshments, so please help yourself to any refreshments back there. Oh, and we brewed some more coffee, so there's also coffee back there if you want. So we'll get started in just a couple of minutes here. And there are also, if we have too many people, there are extra chairs in the back there. So.
Yeah, we get them in our email.
That would make us Okay, we're going to go ahead and get started tonight. As I said, there are more chairs in the back. People come in later and need chairs. There are some along the back wall. So we're going to go ahead and get started. Let's open with prayer tonight, please. So if you'll put your hands. Heavenly Father, we thank you so much for this wonderful evening and the chance to get together to study your glorious creation. We ask your blessings on our speaker, and we pray that you'll open our hearts and minds and give us understanding of your word. In Jesus' name we pray. Amen. Again, as I said, welcome to everyone tonight. And we're looking forward to an exciting presentation here. This is great to see so many people here tonight. Okay, so here's our agenda for tonight. We have already accomplished the first two items, and we're ready to introduce our speaker. When Dr. Hebert is finished, we'll have probably about 10 minutes of Q&A where you can ask some questions. And I have a few announcements, and we'll close with the Lord's Prayer, and with him, morning has broken. Right, I'd like to introduce our speaker tonight, Dr. Jake Hebert from the Institute for Creation Research. Dr. Hebert earned a master's degree in physics in 1999 from Texas A&M University and a PhD in physics in 2011 from the University of Texas in Dallas, where he did cutting-edge research on the connection between cosmic rays, solar activity, and weather and climate. He's taught at both the high school and the university levels. He joined ICR in 2011 as a research associate and is currently researching the post-flood ice age, the dating methods used to assign ages to the seafloor sediments and deep ice cores and cosmology, among other research endeavors. It sounds like that's enough to keep you busy. He's an author. He's written The Ice Age and the Flood. Does science really show millions of years? And the climate change conflict, keeping cool over global warming. And I think we have a couple of copies of that on the back table. He's also a contributor to the Guide to Creation Basics and Beyond, and Guide to the Universe. We're very, very pleased to have Dr. Hebert with us tonight. So please welcome him.
Oh, okay, can you hear me? Is that on? Okay, all right. Yeah, most of my research is in Ice Age stuff. I know just enough cosmology to be dangerous. Okay? This evening we're talking about the mystery of the Ice Age, and this is something that a lot of Christians wonder about. Was there an Ice Age? And they also have other questions that go along with that. Weren't there many Ice Ages? We're told by secular scientists there were many Ice Ages. And we get the impression, watching TV and reading magazines, that they understand what causes Ice Ages. What about the woolly mammoths? How did those fit into biblical history? And do the deep ice cores prove millions of years? There are many people out there who think that deep ice cores are a slam dunk argument for an old Earth. And when you have these discussions about the Ice Age, you will frequently hear discussions about deep time. Hundreds of thousands of years, millions of years, those phrases are thrown around all the time. And of course it raises the question, is the Bible wrong about Earth history? Because there's no hint of millions of years anywhere in the Bible. Now there is strong evidence for an Ice Age. When glaciers melt back, they leave behind certain geological features that indicate the glaciers have been there. And we see those features at lower latitudes and elevations where today there is no ice. And that's a very strong argument that the ice sheets once extended farther down to lower latitudes and elevations than they do today. But this conclusion of millions of years is not demanded by the data. And it's coming from a philosophy called uniformitarianism. I'm sure many of you are familiar with that. And basically it's summarized by the motto that the present is the key to the past. And so a uniformitarian geologist would say that because erosion is slow today, it's always been slow. It's always been slow and gradual. And so the Grand Canyon, presumably, was formed slowly over millions of years. If they apply uniformitarianism to the solar system, they would claim that the planets have been pretty much doing what they've been doing for billions of years. That you can run those astronomical motions backwards into the far distant past. If you apply it to, say, the seafloor sediments, today's seafloor sediments are accumulating very slowly on the ocean floor. They would say that's always been true. And they would say that today, believe it or not, in Antarctica, the snowfall is not that fast. And it's relatively slow, and so they would say, well, it's always been that slow. Okay, now for a uniformitarian, special creation and the Genesis flood are not on the table for discussion. And the Apostle Peter told us that there would come in the last days scoffers who hold to a uniformitarian philosophy. And in his second epistle he says, knowing this first, that scoffers will come in the last days, walking according to their own lust and saying, where is the promise of his coming? For since the fathers fell asleep, all things continue as they were from the beginning of creation. And that is a very good description or summary of the uniformitarian philosophy. But what I want to argue this evening is that that belief in millions of years is holding back uniformitarian scientists, and that we can make better sense of the data than they can. And so how do we make sense of an ice age? Well, the first point I want to make is that uniformitarian explanations for an ice age don't work. They've got dozens of theories. In fact, I think now the number's over 100. And they keep coming up with new ones, even within the last few years. And back in the late 90s, U.S. News and World Report said this is one of the great science mysteries. Now, you might naively think, well, in order to get an ice age, don't you just need colder temperatures? It turns out it's not that simple. Because when the moisture in the air dramatically decreases when you get colder temperatures. So what happens is, if it gets too cold, you actually get less snow, not more. And that's one of the big problems with their ideas for trying to explain an ice age. Now, the theory that's really popular right now is called the Milankovitch astronomical theory. It's named after a Serbian scientist who did a lot of work in this area. They call it the astronomical theory because it involves Earth's astronomical motions. Now, if you believe that the Earth has been in existence and orbiting the sun for billions of years, and you run those motions backwards like a uniformitarian would, it turns out that there are these cycles. The tilt of the Earth's axis, right now it's about 22.5 degrees, but it slowly changes. And over 41,000 years, you would have a tilt cycle. And the shape of the orbit is slowly changing. It's becoming slightly more circular and slightly less circular. The direction in which the Earth's axis is pointing is slowly changing. And as a result of those slow changes, you would have changes in the way sunlight is falling on the Earth. It would vary with season and latitude. And basically, this theory in a nutshell says that controls the timing of ice ages. So there's going to be some times in the prehistoric past where you have less summer sunlight falling on the high latitude ice sheets. Presumably that kept them from melting, and so you had these big ice sheets. The ice sheets got bigger. But there would be other times in the prehistoric past where you had more summer sunlight falling on those high latitude ice sheets, and that would enable the ice to melt back, and you'd have a warm period, what they would call an interglacial. Now, there's all kinds of problems with this theory. The first is that these changes in sunlight are very small, and it's hard to see how that by itself could cause an ice age. And so secular scientists, many of them have convinced themselves that somehow our climate system is amplifying these small changes in order to bring about drastic climate change. And so this is one of the areas where a belief in the Milankovitch theory is contributing to fear over global warming, because they've convinced themselves that our climate is unstable, and all it takes is a little push to nudge us into an entirely different kind of climate. There's also many things about the theory that just don't really make sense. Lots of little things. You get a textbook on this subject. There's about 6, probably 9 different problems. Things about this theory that just don't make sense. And there's an iconic argument for this theory that really became invalid a number of years ago. And this paper is called The Pacemaker of the Ice Ages. It's a very famous paper that was published in the journal Science. And this paper purported to give evidence that the Milankovitch theory was correct. And what they did was they extracted these cores that were drilled from the ocean floor, and you can make chemical measurements in those sediment cores. And they calculated a number that they call the oxygen isotope ratio, and it's supposed to tell you how much ice is on the planet at a given time in the past. Now, there was a paper that pacemaker paper referred to. It was reference number 31. And if you read the fine print, what you find is that when they did their analysis that supposedly confirmed this theory, they used an age of 700,000 years for the most recent flip or reversal of the Earth's magnetic field. Now, we creation scientists think those reversals were associated with the Genesis flood. But back in 1976, they said this reversal happened 700,000 years ago, and then they turned the crank and got their results. Well, the problem is, over 25 years ago, they revised that number to 780,000 years. but they never went back to see how that would affect the original results. Now, actually, I think somebody did go back, but I don't think those results were ever published. So this kind of give you a feel for what's going on here. I don't want to get too technical here, but this kind of graph is called a power spectrum. And the numbers on the horizontal axis, that's frequency, cycles per 1,000 years. And those vertical lines are the frequencies that are predicted by the Milankovitch theory. Okay? Now the peaks that you see, those are the frequencies that are coming from the seafloor sediments. Okay? Those are supposed to be climate frequencies. And what you see in that first image there is that they're lining up pretty good. Okay? The peaks are doing a pretty good job lining up with those vertical lines. And that was seen as strong evidence for this theory. So what happens when you take into account that age revision? Well, 2 of those peaks have been knocked out of alignment, and the 3rd peak is still in alignment, but you can make a strong case that that's a fluke, because you very often get those kind of strong peaks in that part of the frequency spectrum when you're dealing with these kind of data. So basically what happened was they undermined their own argument for this theory, but they never really told anybody. In fact, in 2016, both Nature and Science still said that this paper was the smoking gun of the Ice Ages. This was the paper that gave confirmation that the theory was correct. So this is a very important paper in their thinking. Now, if you'd like to learn more about this, we have a bunch of articles at ICR.org talking about this. Milankovitch meltdown, we've got a series of articles. And if you want to actually read the technical papers that I wrote, there are active hyperlinks that will take you to the technical papers. If you want the technical details, you can get them. But also, now it turns out, though, that around 1997, they came out with this paper. And I think if you read between the lines, this paper was an attempt to prop up the pacemaker paper. I think this paper was meant to be a replacement for that 1973 paper. Now, they never came out and said that, but if you read the book, the Climate Change Conflict, that little booklet that we have, it kind of explains why this is. So they got all these problems with explaining an ice age. And let me get back to how this Milankovitch theory is contributing to climate change alarmism. Okay, they've convinced themselves that the Milankovitch theory is correct, even though the evidence for it is very weak at best, maybe non-existent. But they also know the changes in sunlight are too small to do the job. So they've convinced themselves that something is amplifying the effect. And guess what one of those factors is? CO2. Carbon dioxide, yeah. Okay, so this Milankovitch theory is helping make contributions to climate change alarmism. And again, if you'd like to learn more about that, we have that little booklet, the Climate Change Conflict, that goes into detail about that. So their explanations don't work. That's the first point. The second point is there was only one ice age and it happened recently. Now, if you read the secular textbooks, they will tell you that there were 50 ice ages within the last 2.5 million years or so. Okay, now that's not coming from the geological evidence. Okay, it can't possibly be coming from the geological evidence. Because even if you had 50 different ice ages, guess what? The glaciers from the next ice age are going to bulldoze and destroy the geological evidence for the previous ice age. So there is no way that you could possibly ever see evidence for 50 ice ages in those glacial deposits. Okay, it's just not going to happen. Okay? When you look at those, these are kind of hard to interpret. We think there's really just strong evidence for one ice age. So where are they getting this idea of 50 ice ages? Well, it's coming from the seafloor sediments. Okay, what they did was they took 57 different sediment cores from all over the world. They used the Milankovitch theory to date those cores. See, once they convinced themselves that the Milankovitch theory was correct, then they started using the Milankovitch theory to date other sediment cores. Okay, it's called orbital tuning. And so what happened was they made this composite data set where they stuck them all together. They used the Milankovitch theory to date them. And anybody want to take a guess about how many wiggle cycles you've got here? I'm not going to wait for you to count them, but I'll give you a hint. It's about 50. Okay? That's where it's coming from. That's where the claim of 50 ice ages is coming from. It's not coming from the geological evidence. It's coming from a very shaky interpretation of the seafloor sediment data. Okay? Now, the glacial features, when you look at them, there's little erosion. And even the evolutionists would say that these are like from the most recent ice age, which was relatively recently. Okay, that doesn't necessarily prove that our model is correct. But when you look at these, there's not a lot of evidence of erosion, and that suggests it was in the recent past. Now, we think there was only one ice age, and our best guess is that it probably lasted about 700 years. Okay? And the third point here, and I want to spend a lot of time on this, is that the Bible explains this ice age. Now, in order to get, I've told you how not to get an ice age, right? So if you wanted an ice age, what is the one requirement you would need to get an ice age? And basically, you need to keep the snow and ice from melting for many consecutive summers. So the idea is that during one winter, you have snow and ice that's deposited. And if you can keep most or all of that snow and ice from melting the following summer, the next winter you get more snow and ice. And if you can keep that snow and ice from melting, the next winter you get more snow and ice. Eventually you're going to get these thick ice sheets. And we know there were these ice sheets. So if I had to give you just a one-sentence requirement for an ice age, you've got to keep that snow and ice from melting for many consecutive summers. And you need two things to make that happen. Obviously, you're going to need cooler summers to keep the snow and ice from melting. But you also need heavy snowfall, because even if you have a cool summer, if the snowfall is light, it can still be melted. It can still melt. By the sunshine, it can still melt. So you need both of those things. And Mike Ward is a respected creation researcher who used to be a professional meteorologist for the National Weather Service, and we call him Mr. Ice Age because he's come up with a very good explanation for the Ice Age. And I use this little acrostic HEAT to help people remember the key points. Yes, that's my big contribution to creation science. Okay? I came up with an acrostic for Mike Ward's Ice Age theory. But the H stands for hot oceans. And what I want to do now is I want to let you listen to atmospheric scientist Larry Vardaman. He retired from ICR a number of years ago. But he's explaining how hot oceans can explain an ice age.
When the heat came up from the plates in the oceans, it caused the oceans to become very warm. And it would be like a giant El Nino effect. Well, can you imagine if the oceans were 20, 30, 40 degrees warmer than they are today? We would expect all kinds of severe weather, gigantic hurricanes, which I call hypercanes. And this would produce all kinds of evaporation into the atmosphere, which could then come out as snow in polar regions and on mountaintops. I modeled that with conventional models with a sea surface temperature hotter than we would normally experience today. When that happens, these models predict much, much greater precipitation rates, particularly in the polar regions and on mountaintops. And we can explain the ice age in less than 500 years simply by the warmth of the ocean.
Okay. So if you can somehow warm up the ocean significantly, that's going to give you more evaporation. Okay? And he mentioned plate motions. We're going to come back to that point here in a little bit. But for right now, let's just hypothesize that somehow we can warm up the oceans maybe 10 or 20 degrees Celsius. You're going to get a lot more evaporation. Okay? And then that's going to give you more snowfall. And by the way, you're not going to just get more snowfall. At lower latitudes, you're going to get more rain as well. But you're going to get more snowfall at higher altitudes and elevations. So that's going to give you the snow. That's going to give you the snow to get the ice age started. But remember, we still have to keep the snow and ice from melting. And that's where the A comes in. That stands for aerosols. Aerosols are tiny particles or droplets. And when you have big, explosive volcanic eruptions, you get these droplets, these aerosols, that end up in the stratosphere, and they reflect a lot of sunlight. And you get cooler summers. Okay? Summers are actually cooler. And that's good. That would keep the snow and ice from melting, right? Okay, that's what you need to keep the snow and ice from melting. Now that may sound fairly straightforward. Okay, so you may be wondering to yourself, well, that sounds pretty simple. So if there was an ice age, and we know of conditions that could cause an ice age, then why is this such a mystery to secular scientists? It's because the conditions you need aren't uniform. Remember I mentioned heating up the oceans 10 or 20 degrees Celsius? How do you do that? Where do you get the energy to do something like that? The volcanic cooling, that's a good idea, but there's a possible problem with it. Those aerosols only normally stay up in the stratosphere 2 or 3 years, and then they fall out. So one set of eruptions isn't going to do it. You would need repeated eruptions to make this work. Okay? And that's where the T comes in, and that stands for time. This is the, and not just any time, but the Bible's short time scale is the key to making this work. You see, both creation and secular scientists agree that there has been a frightening amount of volcanic activity in Earth history. I mean, there were volcanic eruptions that dwarf anything that we see today. And both creation and secular scientists agree that if you have these explosive volcanic eruptions, they can give you the necessary summer cooling. So why can't secular scientists use that to explain an ice age? Well, the answer is pretty simple. Because they insist that those eruptions were separated by millions of years. And if you separate them by millions of years, the cooling effect is so diluted, it's not going to do anything. Those eruptions have to occur close together in time in order to make this work. Okay? So does the Bible give us a clue about an event that could cause an ice age? And of course it does. In Genesis chapter 7, verse 11, it says, on that day, the day the flood started, the fountains, all the fountains of the great deep were broken up. And creation scientists think that implies a lot of volcanic and tectonic activity. In fact, we would argue that, when you see the mid-ocean ridge on the ocean floor today, people talk about continental drift and act as if that's an argument for an old Earth, and we're saying, no, that's a scar from the flood. We're saying that plate tectonics played a major role in the flood cataclysm, but it wasn't a slow and gradual continental drift like they're telling you. It was a rapid continental sprint. And John Baumgartner is one of the world's leading experts in this field, maybe the world's leading expert. He's done a tremendous amount of work modeling how this could happen. And he's done some other work much more recently than this. But we think that catastrophic plate tectonics is a key role here, because if you have rapid seafloor spreading, the plates are moving apart rapidly, new seafloor is being formed rapidly. Now today, new seafloor is being formed, but it's being formed very slowly at the mid-ocean ridge. And you get this lava that comes up and it hardens into new seafloor. But we're saying that this was happening much faster during the Genesis flood, and all that heat is going to warm up the oceans. And so you've got a mechanism here that can provide the warmer oceans, but can it also provide many years of volcanic activity? And we think it can. Because remember, the flood is this cataclysm. And so you're going to have all this volcanism, but that volcanic activity is not going to come to a screeching halt at the end of the flood. There's going to be aftershocks. This is going to keep going for hundreds of years, and you're going to have these sporadic volcanic eruptions for hundreds of years, and those will put more aerosols back into the stratosphere and give you the cooling you need for an ice age. Basically, in summary, we're saying that the flood warmed up the oceans. You had hot oceans that resulted in much more evaporation. That resulted in more snowfall. You had these big aerosols from volcanic eruptions. That gave you the summer cooling from the reflected sunlight to keep the snow and ice from melting. And ultimately, the Bible's short time scale is what makes it work. And of course, we got that little acrostic heat to help you remember those key points. It also helps us explain past climate change. We talk about the fact that you had more snowfall, and I mentioned this already, there was more rainfall as well. And there's lots of areas on Earth today that are just bone dry today, but in the recent past, they were getting much more rainfall, like the Sahara. It was getting abundant rainfall not that long ago. So was the American Southwest. You had these big lakes. In fact, the Great Salt Lake is just a small remnant of a much larger lake called Lake Bonneville. And we think part of this because you got standing water after the flood, but also the precipitation kept those lakes replenished for quite some time after the flood. The Dead Sea region, it's described as a well-watered land in Genesis 13, even though today it's just barren. The Promised Land is described as a land flowing with milk and honey. And we think possibly that more precipitation that you had after the flood during the Ice Age may help explain this. In fact, we don't think it's a coincidence that there's more references to ice, snow, and cold in the book of Job than any other book of the Bible. Now, Job lived in the Middle East, and we don't think the ice sheets didn't come down to the Middle East, but it's possible that someone may have described those ice sheets to him, and that's why God mentions these here. But it's also possible that the Middle East at that time may have just been getting more snow and ice than it does today. In Job 37:9, from the chamber of the south comes the whirlwind, and cold from the scattering winds of the north. Have you entered the treasury of snow, or have you seen the treasury of hail? From whose womb comes the ice and the frost of heaven, who gives it birth? So we're thinking that's a clue that right after the flood, the climate was different. And we think the Bible helps explain that. Now, also, a lot of people wonder about woolly mammoths. Woolly mammoths aren't quite as cool as dinosaurs, but they're kind of cool. And a lot of people wonder about them because they're kind of fascinating. But woolly mammoths really are an enigma to secular scientists. One thing that is very hard for them to explain about that is we have good reason to believe there were millions of woolly mammoths living in Siberia during an ice age, or during the ice age. And as we're going to see here in a moment, that's tough to explain. And also, you've got to explain why they became extinct. Now, why is it problematic having woolly mammoths in Siberia? It's because the winters there today are extremely cold. Minimum temperatures of minus 40 degrees Fahrenheit are typical, and sometimes it can be minus 98 degrees Fahrenheit. Okay? And it's really hard to see how even the woolly mammoths could tolerate that. And even if they could, where are they going to get food and water in sufficient quantities to prosper and thrive in Siberia? Okay, well, as it turns out, the flood model gives us an answer to that. And remember what we said earlier, you have warm oceans, and those oceans are going to stay warm for hundreds of years after the flood. And it's not going to just be at the lower latitudes. The oceans are going to be warmer all over the world, including at the North Pole. And so we think after the flood, there was no Arctic sea ice originally. We think the Arctic sea ice formed at the end of the Ice Age. So you have this warm Arctic Ocean next to Siberia, and that's going to help moderate the climate. This is kind of amusing. This was actually showed up on the University of Illinois website. Apparently there's a computer glitch where they accidentally made all the Antarctic sea ice, or the Arctic sea ice disappear. Didn't really happen, obviously, but that shows you what it would look like without Arctic sea ice. And so we think this helps explain why, even though it's cold in Siberia, it's not as cold as it is today. Okay, Seattle, Washington's a good example. It's farther north than New York City, but you have warm, moist air from the Pacific that helps moderate that climate. And so we think something similar was going on during the Ice Age. And that's a very simple, common sense explanation for this. So why can't the evolutionists use it? Why can't uniformitarian scientists use this to explain how you could have millions of woolly mammoths in Siberia? And the answer is very simple. It gets back to their belief in millions of years. Because they believe that Arctic sea ice has been there for at least 100,000 years. And the mammoths, according to their reckoning, only went extinct maybe like 11,000 years ago. So presumably, you had woolly mammoths during thousands of years of unbelievably cold temperatures, and then for some reason, 11,000 years ago, they died off. Okay? Their millions of years is making it harder for them to explain this. The simple answer is there wasn't any Arctic sea ice, and that moderated the climate so they could endure the winters in Siberia. It just flat out wasn't as cold as it is today. Now, what happened to them? Mike Ward has done a lot of work on this, and I don't want to spend too much time on this, but we think, ironically, the weather got colder at the end of the Ice Age. And there's reasons for that. You know, the fresh water on the land, when it melts, it flows out onto the Arctic, it freezes, You no longer have that moderating influence, and so you get this drop in temperature. And also, that's going to set up a temperature difference between the polar and equatorial regions. And we think things were drying out at the end of the Ice Age. And so you get these big dust storms. In fact, it's not, I don't think it's a coincidence. Some of these mammoth remains are found in these frozen hills of wind-blown silt. And we think basically what happened was some of them just got buried alive by those dust storms, and then the dust froze around them afterwards. So if you'd like to learn more about this, we have some articles on our website dealing with the subject. And another thing that the Bible helps us understand are these Greenland and Antarctic ice sheets. Now, there's thick ice sheets in Greenland and Antarctica, and some skeptics think that these, they drill these cores and they extract these long cores from the ice. And some skeptics, like Bill Nye, the science guy, think this is an unanswerable argument for an old Earth. They think it's a slam dunk argument because they claim that they have counted more than 100,000 annual layers in one of these deep Greenland ice cores. So let's talk about that. Do these ice cores really prove millions of years? Well, it turns out the most common method of dating the ice cores are theoretical age models. And that's especially true in Antarctica. There's not enough annual snowfall in Antarctica to see annual layers. So they're dependent on these theoretical models to figure out how thick the layers are. Here in this little picture, you've got these nice, convenient horizontal blue lines to let you see where the layers are. Well, unfortunately, you don't have that in the ice, right? So they use a model to figure out how thick the layers are and how many of them there are. But those models implicitly assume that the ice sheet has been there for millions of years. So those models assume millions of years. Therefore, the fact that you're getting vast ages from these models is not surprising. So the Antarctic ice cores are almost trivial to explain. Okay, their age models are naturally going to produce vast ages. But what about Greenland? Now, Greenland at first glance seems to be a much stronger argument for an old Earth because, as I said earlier, they claim that they counted more than 100,000 annual layers in this one particular ice core from central Greenland. Now, in order to understand why I don't think this is a slam dunk argument for an old Earth, we kind of have to understand how they dated this particular ice core. And there were two main sections of the core. The top half of the core, we're going to see they actually did count visible layers. Okay. Now, that was the upper half of the core down to a depth of about 1,500 meters. And then when you got down to 2,800 meters, they said that ice was 110,000 years old. Now, this is not as easy as everybody thinks it is, because a lot of people think, well, maybe you have one layer per year, or maybe 2 layers per year, one summer, one winter. It's not like that at all. You have multiple layers per year, and the number of layers can vary from year to year. So they have to make an educated guess about how many of those layers should be grouped together and counted as a year. It's an educated guess, but it is a guess. Okay? So you might be interested in wondering, what age did they assign halfway down that core to a depth of 1,500 meters? Now, before you answer, remember, they're claiming this ice down here is 110,000 years old. So anybody want to venture a guess as to what age they assigned here? Don't be bashful. 50,000. Okay, somebody threw out 50,000. Anybody want to go higher or lower? 40,000.
15.
15. You're getting warmer.
6,000.
About 10.
They're very close. They assigned an age of 9,300 years to that ice.
Oh, that's accurate.
Okay, now, but here's the point. Here's the point I want to make to you. Both creation scientists and secular scientists would agree that this marks the end of the Ice Age. Now, we think the Ice Age lasted, maybe 700 years. Let's use a round number of 500 years. If the flood was 4,500 years ago, that would make this ice 4,000 years old. Now, why is that important? Because both the creationists and uniformitarians are getting in the same ballpark. Okay, they're within a factor of 2 or 3, so there's not that much disagreement. Okay, there's enough uncertainty in the counting that, you know, it's not too surprising that they might overstate the true number by maybe 2 or 3. But what that also means is that means nearly all of that alleged time is in the bottom half of the core. They're claiming that you have more than 100,000 years in the bottom half of that core. So if you're going to understand how they got that, you have to understand what they did. And what they did here was they counted dust peaks. Okay, you see there's a seasonal dust cycle. And they assumed every time you have a peak in the amount of dust in the ice, that represents a spring or summer. And so they counted them up, and that's how they got their age of about 110,000 years down at the bottom. Now, there's problems with this. Okay, first, individual snowstorms can cause the amount of dust to vary. And we think conservatively there would have been thousands of those winter storms during the Ice Age. So you've got a seasonal cycle, but then you've got all this other stuff going on as well that's going to confuse and muddle the signal. Another big problem is that the amount of dust in the bottom sections of the cores is very high, but even more than that, it's very variable. Okay, and I want to show you this picture. The figure on the right, oops, I'm sorry, that's actual data from a Greenland core. And what you're seeing here, that's the dust. There's hardly any dust here, but when you get down to the Ice Age ice, boom, you got all that dust. And not only is it high, it's jumping around. Okay, the amount of dust in the bottom sections of those cores can vary from anywhere to about 3 to 100 times what's in the top of the core. Okay, so it's jumping around. Now, why is that a problem? Okay, I want to illustrate this for you. Now, this is not a trick question. How many dust peaks do you see right there? 2, right. Now, I want to point out, why was it so easy to see those 2 dust peaks? It's something that you might not even think about at first. Well, part of it is because both peaks are approximately the same height, and there's a clearly defined, baseline. You know, you can tell where the baseline is. So it's easy to count those dust peaks. What happens, though, if the dust is actually jumping around like this? You see the problem? Now it's a lot harder. Okay, where's the baseline? Okay, it's not as obvious. And so that's going to make it much easier for you to mess up when you're making these counts. Also, the number of counted peaks is very subjective. First, how close together do you make your measurements? Remember, the dust, that's continuously varying. So the more measurements you make, the more jumps you're going to see. And I've got a little chart to illustrate this. Again, you can see here, and I make this as sort of a little representation. Let's say you've got an ice core and you're measuring dust. And let's say you make 5 measurements. Okay, well, if you make 5 measurements, you're going to see 1 peak. But if you make 15 measurements, guess what? You're going to see a lot more variation. Okay? So now, the more measurements you make, the more peaks you're going to see. And so you could have maybe 3 peaks here. Now, why is that a problem? Well, the secular age models say that the annual layers get very thin as you go deep into the core. So they think they've got to make those measurements close together. And so that's going to bias them to higher numbers. And also, you've got this problem of, do you count a small peak? How big does the peak have to be before it counts as a seasonal change? So all those things together greatly complicate this. And so I don't think this is a strong argument for an old Earth. Certainly not as strong as they think it is. So if you'd like to learn more about that, we've got an entire section on our website devoted to the ice cores. So I think we can plausibly account for the overcounting in the Greenland ice cores. And I don't think they've got any strong evidence for millions of years. In fact, there's clues in those cores that strongly suggest that they're younger than that. And if you like, we can talk about that during the Q&A. But can ice sheets form in 4,500 years? Yes. Even the secular scientists acknowledge you can get thick ice sheets in roughly 10,000 years, even with today's slow and gradual accumulation rates. But if it was higher during the flood, and remember, you're going to have more snowfall during the Ice Age after the flood, you're going to need less time for those ice sheets to form. And so we think we can plausibly account for the formation of those ice sheets in the 4,500 years since the flood. Okay? So we can make better sense of an ice age than the secular scientists can. Their uniformitarian explanations don't work. There was just one ice age, and it happened recently, and the Bible explains that ice age. It gives us a mechanism for explaining the ice age itself, that little heat mechanism, but it also helps explain past climate change, the woolly mammoths, and the Greenland and Antarctic ice sheets. Okay? By the way, you might be wondering, volcanism is a really big, important part of the flood ice age model, right? We think there was a lot of volcanic activity during the ice age. You think maybe if we look at some of those ice cores, we might find evidence for that? Well, as a matter of fact, we do. Okay? The secular scientists claim that there were hundreds of big volcanic eruptions in the ice age portion of that ice core. And they were big enough to actually influence the climate. I think they said around 700. Now, if you have 700 eruptions over 100,000 years, that's no big deal, right? But what if you have 700 big explosive eruptions in the old 500 years? Okay, then you've got a potent mechanism for an ice age. Okay? So again, I hope this little talk's been encouraging to you. And I want to point out that the uniformitarians, they cannot explain the ice age. That is the most recent major geological event in our history. So if they can't explain that, then why should we trust them when they're telling us these stories, these grandiose stories about stuff that supposedly happened millions of years ago? The Bible really is a key to understanding Earth history. If you aren't getting our magazine, Acts and Facts, I hope you'll sign up for it. We have a sign-up sheet back at that back table. It's free to you. It's paid for by our donors. But it's a glossy magazine, and every month we answer these tough questions about creation versus evolution. We've also got some recent, well, we don't have them here, but if you think you'd like to learn more about this, we've got a little booklet that I did on the Ice Age and the Flood, and basically it's talking about the ice cores and why the ice cores are not a strong argument for an old Earth. That one's a little bit technical. We've also got an Ice Age DVD that covers some of what I did here as well, but a lot of stuff I didn't cover. And then we've got our climate change conflict booklet, which deals into more how the Milankovitch theory is contributing to climate change alarmism. And if you're ever down in the Dallas DFW area, we hope you'll come by and see our Discovery Center for Science and Earth History. And I hope this little talk's been an encouragement to you, and I'll hand it back over to Judy. Thank you.
Okay, let's thank Dr. Hebert.
Oh, sure. Do I need to advance this right now? Okay, all right.
Okay, so we're going to take, can you hear me? Yeah. Okay, we're going to take about 10 minutes here and do a question-answer session. I'm going to come around with the mic because we are recording this to put it on our website. It should be out there within a week or so that if you want to see it again, you can do that. And so I'm going to come around with the mic. I'd ask you please to keep your questions brief because we want to try to hold the question and answer session to about 10 minutes. So, yes.
In connection with the Greenland, there were during World War II,
Right.
we had several airplanes that crash landed on the ice.
Right.
And I think they were buried with successive ice storms and the depth, and then eventually they drilled down to find them years later,
Right.
and they were I forget how many hundreds of feet.
Well, it was like 250 feet.
Which would equate to how many years?
Well, okay, there's a nuance to that argument you kind of have to be careful of. Okay, here's when somebody first made that argument, the evolutionists cried foul, and they kind of had a point because they said, well, look, guys, the snowfall in southeastern Greenland is way higher than it is in central Greenland. Okay, so you're using the southeast Greenland to show that ice and snow can accumulate rapidly. But that's irrelevant because the deep cores are in central Greenland where the snowfall is a lot less. Okay, and admittedly they had a point. But let's think about this also. Remember, we're also saying that there was much heavier snowfall during the Ice Age. And that would be true even in central Greenland. So if you keep that in mind, that's an illustration when you have a very high precipitation rate of how thick ice can form rapidly. Okay? But you don't want to forget that part of the argument, because they cried foul, and they had a point, okay? Because, you know, again, southeast Greenland, you got a lot of snowfall, okay? Central Greenland, where the deep cores are, you don't. But we're saying that during the Ice Age, there were the kind of snowfall you're seeing in southeast Greenland today, that's the kind of snowfall you saw during the Ice Age.
Let me segue to that first before I ask my question.
Okay.
I spent a year in Greenland with the Air Force. Greenland gets zero precipitation up in the higher latitudes. It all blows back and forth. We get phase storms, phase 1, phase 2, phase 3, wind can blow 100 miles an hour. So the ice sheets that were formed there during the Ice Age, chances are there hasn't been much formation since then. It just blows around.
Okay.
I was there for a year. We never got snowfall in Greenland. But we had these phase storms that showed up all the time, and it locked everything down for days at a time.
Okay.
And the wind would blow 100 miles an hour. And like you said, it's 40 below. And
Right.
then when the wind blows, it gets cold.
Sure.
So
Yeah.
you have to take that into consideration as well. With Greenland.
Oh, yeah.
Now the other question, the real question I had was the extent of the ice sheets. We talked about the formation and the dynamics of it all. I haven't heard anybody talk very much about how far they extended in the northern latitudes, which we would be familiar with, and the southern latitudes.
Okay, well, I think as far as the extent of the ice sheets, I think creationists would probably agree with the evolutionists on the extent of the ice, because you know, you're using glacial deposits to infer that. Now, we do think, though, the ice sheets were a lot thinner than what the evolutionists claim. Okay, and there's a couple of reasons they think that for instance, the ice sheets in North America were very thick. One of the reasons is they're just making an analogy with the ice sheets in Antarctica and Greenland. And so since they're thick, they assume these also must have been thick. But there's also a more subtle reason they think the ice sheets had to be very thick. And that's because they think the ice started small and expanded outwards toward the south. The problem is, in order for that to happen, it has to go uphill. Okay, now that can happen, but it only works if you have a really thick ice sheet. And so so that's one of the reasons they think the ice sheets had to be very thick. And we disagree with that. We think there's not very strong evidence. We think the ice sheets were a lot thinner than what they're claiming. But as far as the extent, I think we would probably be in pretty much agreement. Oh, by the way, just to clarify on that, when we say there was an ice age, we're not saying the entire planet was frozen. Okay, some people have that misimpression. Now, the evolutionists think that in billions of years ago, the entire Earth was frozen. Okay, they call it snowball Earth. But the evidence for that is actually pretty weak, and we think they're misinterpreting the data.
Good evening. Thank you so much. I'm going to take this a little bit of a different direction. I'm curious about your thoughts, kind of as you look into your crystal ball, on sunspots, the mini ice age of the past, and what is maybe coming in the next 50 years or so.
Well, I tell you what, it's kind of interesting you should mention that, because my PhD research was extreme. That was basically what it was on. And the next issue of Acts and Facts it's got a 2-part series on that. It's not my own theory. My advisor at UTD, who by the way is not a creationist, okay, he was working on that for probably about 20 years before I started working for him. And I think he's figured it out. I think he's got the correct explanation for the real connection between sunspots, cosmic rays, and weather and climate. Now, if you read up on this kind of thing, and I can't explain it in a soundbite, okay? But if you sign up for Acts and Facts, the very next issue we got a big picture of the sun on it, okay? But one of the things he's expecting is that when you have very, very low solar activity, low sunspot number, he thinks that basically you're going to get cold winters in the UK and in Europe. And there's a chain of reasoning he uses to reach that. And of course, what's interesting is that's exactly what happened during the Maunder Minima, which was the coldest part of the Little Ice Age. Now, that doesn't necessarily mean it's a global effect, but that's something he is very much expecting and predicting. So we're basically entering a grand solar minimum that they think could last who knows how long. He thinks that you should expect to see really cold European winters, especially, there's something called a quasi-biennial oscillation, and when it's in its western phase, the effect seems to be more pronounced. But I can't do it in a soundbite, okay? But if you get acts and facts, next two issues, we got articles dealing with that.
So if I were to take a bottle of a lot of different sized particles and shake it all up, kind of like in a global flood, you tend to find your largest pieces coming out first, and then smaller and smaller falling out on top of that, right?
I don't know if that, well, I will tell you this. I do know that a lot of the ideas that people have had about the way these deposits form has been wrong. You know, for the longest, they said basically it was like you had a layer, and then a layer, and then a layer. But what they found in these flume experiments is that you have multiple layers on top of each other forming almost simultaneously. And
so I guess that you're saying the global flood wouldn't pick up all sizes?
well, it's going to pick them up. What are you getting at?
So yeah, what I'm really getting at is the very end part is the mud, which takes days to come out and then falls down and then has to pack down to 20% of what it was before. And so if you go to the North Atlantic and you drill, you get these very thick mud sequences, but towards the middle of them you get these Heinrich events. And here's my question. Heinrich events are these coarse particles in the middle of the North Atlantic, right? And they have coarse material with subangular, sub-rounded, and some polished faces, which is exactly what you get from black glaciers.
I'm going to answer your question.
No, it's not a question yet.
You're mistaken when you assume. You're mistaken when you assume that mud rocks require large amounts of time.
How do you get Heinrich events when there's 5 of them and they look like grafted?
Let me answer your first objection. Let me answer your first objection. The problem is you are falsely assuming that mud rocks cannot form quickly, and we now know that is not true. They found recently, in fact, there was some big papers by secular geologists who said that's just wrong. You can get mud rocks to form rapidly. And so that is not a valid objection against the Genesis flood. Now, as far as Heinrich events, look, we're not disputing that you get cyclical stuff in there, but this is all hinging on your time scale.
But the rocks
and we're saying the time scale is wrong.
North America, and then come back in from North America again in different layers, in which says you're having pulses, and not always from the same place.
Well, you have pulses, but did they happen?
Don't always.
Okay, why don't we take this offline because we've got.
Okay, all right.
Okay. Well, they don't run over the same
Sir,
area.
please,
they run over different areas.
We're going to take this offline.
Well, I think I've answered your question.
Okay. I'm glad to talk to you about this as well. So.
Well, I just had a question. Have you taken into consideration when you guys do all these computations? So I'm a believer that the flood happened. Assuming the flood did happen, all the volcanic activity that happened, during the beginning, you would assume that all the weather patterns, all the extreme weather patterns, like all the wind blowing and the water coming down, does that have an effect on the amount of aerosols in the air? And when when all this is happening, when the aerosols settle after all the initial big event has happened, is that sufficient to come up with the computations you guys have?
Well, let me put it this way. There was, nobody disputes there was an enormous amount of volcanism in Earth history. Okay? The question is, how long did it take? Okay, if you believe it was separated by millions of years, it's not going to really do much. But if that volcanism is the residual effect of the flood, and it's happening in a few hundred years, that is a potent mechanism for an ice age. In fact, even after you've had some of these big eruptions like Mount Pinatubo, there was a slight but noticeable drop in summer temperatures after that. And that was one big eruption. So if you've got multiple eruptions like this going on all over the world, I don't think there's any doubt that that's going to give you the cooler temperatures you need. And I think even the secular guys would recognize that. Okay?
Okay, who else? Any other questions? Take one more here.
So I recall from about maybe the 70s, or it might have even been the 1960s, I was interested in Ice Age kind of stuff. And I remember reading an article that postulated that the reason for ice ages had to do with very warm temperatures and lack of ice in the Arctic. And I'm not familiar with who wrote that, but I must have seen it in a magazine, you know, a National Geographic type magazine or something like that. And so that's one thing. I wondered if you'd been familiar with that.
I don't recall that, but I'll tell you one thing that I did come across that's very interesting. You know, I told you how this Milankovitch paper, the pacemaker paper, they basically shot themselves in the foot. That's not the first time that happened. You see, shortly before that, maybe about 10 years before they came out with this paper, there was another paper that purported to give strong evidence for the Milankovitch theory. But they made an age revision, and it invalidated that one. So this is the second time something like that has happened. And so it just shows you just how shaky the dating methods really are. And they don't have a good, strong case for it.
Thank you. Thank you, Dr. Hebert, very much. And will you be around if people have some questions? Okay, as usual, I have just a few announcements. I'll try to keep them really brief, and then if you'd like to ask Dr. Hebert some more questions, he'll be hanging around, and we'll have a resource table open as well. Next month, we have Mr. Carl Kirby from Reasons for Hope, and he'll be here on March 5th. We'll be meeting here at 7 o'clock at Ascension. Those are his websites if you'd like to check it out. I don't have a topic for him yet, but I'm sure whatever it is, he'll be excellent. So, and he's very good with young people. So I would ask you if you know any young people that would like to come, please bring them because he's excellent with young people. Other February events, we have a lot going on in the Denver area this month. Some of you have heard Rob Carter. He was here. He's been here a couple of times. He'll be in town again Saturday, February 8th at Christ Our Redeemer Lutheran Church in Aurora. And then on Sunday at Lakewood Church of the Nazarene in Lakewood. And then I'm going to be speaking also on February 8th at the Pikes Peak Creation Fellowship in Colorado Springs. That'll be at Faith Evangelical Free Church, and I'll be speaking on the cost of denying creation. The Rocky Mountain Creation Fellowship meets next Friday, February 14th, and their guest will be Dr. Jason Lyles. So if you haven't had an opportunity to hear him, I urge you to go hear him. At Littleton Baptist Church, that's just one block down the street here. And the Northeast Colorado Creation Group will also have Dr. Lyle on Thursday night, February 13th. So just for those of you that don't know, when we started up about 4 years ago, there were 3 that we know of creation groups in Colorado. There are now 5. We have a new one in Fort Lupton and a new one in Colorado Springs, and we're happy to support those groups as they come into being. So just a reminder that we are a 501c3, and if you'd like to help us cover the costs of having speakers in and doing many of our special events, there is a donation box in the back, or you can contribute by mail or on our website. We also have a resource table back there. Again, if you'd like to purchase some resources, I'll be back there after the meeting. And Barbara, maybe would you mind helping me with the books? You can take cash sales, I can take the credit cards. So we'll be back there doing that. And you're also welcome, of course, to ask questions of Dr. Hebert. And then we also have a mailing list sign up on the back table when you came in the door. So if you'd like to get our monthly newsletter and know what's going on in Denver, you're welcome to sign up for that. And also, there are business cards back there, there are brochures, there are conference flyers and information. So just, you're welcome to pick up whatever is on that back table. Okay, I'd like to close tonight with the Lord's Prayer, and then we will sing morning as well. Oh, I'm sorry. We also have one more announcement. We have a couple here, the Batemans, where you guys are right here. Okay, they have a petition to stop abortion. It's Colorado Amendment to Stop Abortion. So if you'd like to sign their petition, please see Mr. Bateman after the meeting. Okay, so let's close with the Lord's Prayer, and then we'll sing Morning Has Broken. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth
understanding. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. For thine is the kingdom, and power, and the glory forever.